Hey, we're here doing some u substitution integration practice, and we're down to number 6. It is integration of the square root of x times the sine of 1 plus x to the 3/2, and that's equal to dx. We don't have to, but anytime I see roots, I like to rewrite them, x to the 1/2. And that's times sine of 1 plus x to the 3/2 dx. So even if you don't rewrite that, you can probably handle the problem. We know how to integrate the sine of a variable, so we're going to have to use u substitution if something more complicated is in there. And I'm going to let 1 plus x to the 3/2 be my u because I know the derivative of x to the 3/2 contains an x to the 1/2. So it's a nice little pair up there. So let's see here. If we let our u be 1 plus x to the 3/2, the derivative of that, du, is 1 goes to 0. So 3/2 comes out front, 3/2 x to the 1/2 dx. Well, up here I see the x to the 1/2 and I see the dx, but I need to do a little bit more work. So I'll divide by that 3/2 and it'll be 2/3 du equal to x to the 1/2 dx. So that's going to be the substitution I make. So I'm going to let 1 plus x to the 3/2 be u, and I'm going to let x to the 1/2 dx be 2/3 du. So when I replace my x's with u's, I will have the integral of 2/3 sine of u du, which becomes integral of sine is negative cosine, so it'll be negative 2/3 cosine u plus c. But then I gotta take my u back to what it was, the 1 plus x to the 3/2. So in the end I'll have negative 2/3 cosine of 1 plus x to the 3/2 plus c. Don't forget about that plus c, because we don't have endpoints. Okay, let's see here. We're going to do another problem here. Let's try and make sure we have some room here. Okay, number 7 is the integration from 0 to 1 of the fraction 24x on top, and on the bottom we have the quantity 4x squared plus 4 squared dx. We have some parentheses here, but let's rewrite a couple things first. I'm going to leave this from 0 to 1. 24x is up top, and I'm going to bring the square part up top using a negative 2 power, because it really looks like it's a power rule reversal problem. I've got this thing to the negative 2 now. I would like to add 1 to it and divide by that new exponent. So what do I have here? I have in parentheses, which is a good indicator, 4x squared plus 4. And I know that derivative of 4x squared is 8x. Well, the x matches up with the outside, and the 4 just by itself will go away. So let's use that. Okay. So u equals 4x squared plus 4. du will be 8x dx. Now that doesn't match up perfectly, and you've got a couple options here you could do. I'm going to do something a little bit different than I usually do, because I'm trying to match up the 24x and the dx. One thing I could do is I could either just ignore the 24 and divide out the 8 and replace it. But let's say I multiply both sides of my du equals 8x dx by 3. If I do that, I'll have 3 du equals 24x dx. So it's an equation. I can do the same thing to both sides. So that gives me something nice that I could replace with. So I can replace my 24x dx with 3 du. So u and 3 du. So when I replace, one thing that's kind of important here is that I don't carry the 1 over and the 0, since they're not u's, they're x's. So let's just say we're going to carry this over, and we'll figure that out in a little bit. But this is going to be 3u to the negative 2 du. And that takes care of everything. So when I integrate that in terms of u, it'll go up to the negative 1, divide by a negative 1, so it'll be negative 3 u to the negative 1. And I could put a plus c on there, but I know I have endpoints, and I also need to take it back to x. So I'm going to take this back to negative 3 times 4x squared plus 4 to the negative 1, and that'll be from 0 to 1. And if you care to, which I just replaced this back, you can go ahead and rewrite that. It's not necessary, but if you say negative 3 over 4x squared plus 4 and run that from 0 to 1, that might make your life a little bit easier just in thinking. So let's see. We'll let x be 1. So in that case, we'll have negative 3 over 4 plus 4. And then we'll let x be 0. And that will give me negative 3 over 0 plus 4, so 4. So I have negative 3/8 plus 3/4, so I think that gives me 3/8 if I'm not mistaken. Okay, so it was a definite integral with endpoints, so we wanted to make sure that we go back to the original variable x and we actually get a number out of it. Okay, let's see where we are next. Let's head to a new page. Number 8. What do we got here? We got the integration of the quantity 1 plus tangent, and all that's to the 5th, times the secant squared d theta. So I don't see any reason to rewrite this, but once again we have some parentheses here with the 1 plus tangent of theta in the parentheses all raised to the 5th. So let's let that be our u. Let's see if that works out for us. So we'll let u be 1 plus tangent theta. So derivative of that, du would be secant squared theta d theta. That is going to be beautiful. So we're letting the 1 plus tangent be u, and then we let the secant squared theta d theta be du. So that matches up perfect. Okay. So in that case, we'll say this thing is just u to the 5th du, which allows me to reverse my power rule. I'll raise u by 1, so it'll be to the 6th. So 1/6 u to the 6th plus c. But let's go ahead and take that back to theta, So that'll be 1/6 times the quantity of 1 plus tangent of theta to the 6th plus c. So just being careful as we go. Okay. So what have we got next? Number 9 here. We've got the integral from 0 to 1 of x times e to the negative x squared dx. Okay, I don't see anything that needs to be rewritten here. But we know how to integrate e to the x, but not e to the negative x squared, so that's where the u substitution will come in. If that was just e to the x, would be okay, as long as the x wasn't out front. Both of those things are giving us a problem, but that's going to be our u. So if u is negative x squared, du will be negative 2x dx. So we could do the same thing we did before, but I'm going to divide out the negative 2. So negative 1/2 du equals x dx. And then we have a perfect substitution. Okay. So in that case, we'll rewrite this. Still has endpoints, I'm just not going to write them. But it'll be negative 1/2 e to the u du. Okay, and we know e to the u is e to the u when we integrate it, so we get negative 1/2 e to the u. We could put a plus c, but we know there's endpoints, so we want to take this back to x. So negative 1/2 e to the negative x squared, and that's running from 0 to 1. So getting everything back in place, when we put it back in terms of x. So we got 2 endpoints, so we need to plug them in. So we'll let x equal 1. So that'll be negative 1/2 e to the negative 1. minus -1 times e to the 0. Okay, so let's see here. This will be -1 over 2e for the -1 exponent, and then we have a minus minus, so that'll be plus. Remember, anything to 0 power is 1, so it'll be plus 1/2. You can leave it like that, or you can make a common denominator, which would be -1 plus e all over 2e. I think that's right. Yes, if you wanted either one of those, you could take it. You can get a decimal approximation, but we're able to get an exact answer there. All right, one more problem. Long video here. Let's see here. We have the integration of the fraction sine of the natural log of x all over x dx. Once again, there's no need to rewrite this, but it might help you see it a little bit better. So I could write it as 1 over x times the sine of natural log of x. And because those parentheses are already here, it's kind of helpful, but if they're not, we know that there's an expression or a function inside the sine function. So we're going to let the natural log be our u. And with that, if u is the natural log of x, then du is 1 over x dx. So we can replace some things very magically matched up here. So let me highlight everything in the correct place, like I've been doing. So we'll have the integration of sine u du, which the integral of sine is negative cosine, so negative cosine of u plus c. And then we'll take it back to the original statement, so negative cosine of the natural log of x plus c. So always remembering to go back to the original variable, and if there's no endpoints, make sure you throw on a plus c. All right, thank you.